So what we're moving into now, the first unit we did in quadratics was graphing the quadratics. Now we need to be able to solve equations that involve quadratic expressions. So you should be very comfortable. You were just quizzed on all of this. This is vertex form of a parabola. If you look at that without doing any work, what does this equation tell me? It tells me the vertex. The vertex is HK, right? That's the vertex. What's the axis of symmetry? X equal H. That is the axis of symmetry, okay? You look at the next form, is intercept form. Dylan, why don't you join us? The next form is intercept form. You can look at this without doing any work and tell what? The x-intercepts. The x-intercepts are going to be at what? P0 and Q0. How do I find the axis of symmetry here? Yeah, it's just halfway in between those 2 points, P plus Q over 2. If you look at the next one in standard form, the only thing I can look without doing any work and telling on this one is what? Yeah, the y-intercept is the point, what, 0, C. Because if you set x equal to 0, you're going to get C as your answer. And then the axis of symmetry in this guy is always what? Negative B over 2A, okay? These are things you were just tested on. They have to stay in your working memory from now until we break up for the Christmas break, okay? So let's take a little bit of a move. What we want to look at now is what happens when I set any of these equations equal to 0. That's what I call solving the equation, setting it equal to 0, okay? So the easiest one to do is this guy right here, okay? If I set this intercept form, if I set this equal to 0, I've got a number times a number times a number. If numbers multiply and my answer is 0, what do I know? Yeah, one of those numbers has to be 0. There's no way to multiply positive numbers and get 0. No way to multiply negative numbers and get 0. So in this one, I know that if this thing equals 0, then one of these things has to be 0. So either x minus p is 0 or x minus q is 0. That means that x is p or x is q. So that tells me this is the solution when I set it equal to 0. Well, sort of duh, we knew that. These are, what are these called? When the y is 0, it's called what? X-intercept. That was the whole point of getting it in this form, is that tells me the x-intercepts. So that one's pretty easy to solve when you set it equal to 0. Now the next one is a little bit next easiest to solve would be the one that's in vertex form that has square roots. What would it mean if I set this guy solved by setting it equal to 0? So if I'm going to set this equation equal to 0, so a x minus h squared plus k equals 0. What I really want to get by itself, I want to solve it for x. What was the first thing I would do to try to get x by itself? I don't want to divide by the first thing I want to do. The first thing I would probably do is just subtract k from both sides. Okay, so I would get a x minus h squared equal negative k. Now what will I do? Divide both sides by a, and I get x minus h squared equal negative k over a. Now I've got something squared equal negative k over a. What will I do to get this one solved? I could take the square root of both sides, okay? So if I take the square root of both sides, I got to do a little bit of work before I can get you to the answer on that one. So this looks a little complicated, but let's talk a little bit about properties of square roots before we come back to solving this guy. Okay, so some properties of square roots and radicals. If I have the square root of a times the square root of b, that's the same as the square root of a times b. So for example, the square root of 2 times the square root of 5, that's the same as the square root of 10. If I had the square root of 32, that's the same as the square root of 2 times 16. How can I simplify this one right here? What's the square root of 16? 4. So this is 4 times the square root of 2. Okay? So you have to be comfortable with the square roots, writing things as factors, and being able to simplify. Same thing, there's a quotient property for radicals. So if I have the square root of, 10 over 3, that's the same as the square root of 10 divided by the square root of 3. Okay. I can break those up into two different radicals. What this is helpful for, and we're going to see several times here, is we're going to be in a situation where we have to simplify radical expressions. Square root of 50. If this were the square root of 49, I would be done, right? What's the square root of 49? 7. There is no integer that makes 50 is not a perfect square. So I can rewrite this as the square root of what? If I write that as the square root of 2 times 25, how does that help me? Yeah. What's the square root of 25? 5. So the answer here is 5 square root of 2. And that's in simplest form. Now you don't need a calculator to give a decimal approximation. This is the exact number. The square root of 50 is 5 times the square root of 2. These are exact representations. Square root of 27. How could I simplify this guy? Write it as what? Yeah, the square root of 3 times 9, because 9 is a perfect square. So this answer is what? Yeah, 3 square root of 3. Okay, you should have done this. I think most of you had geometry last year. I think this was a skill from there, right? Square root of 2 over 25. I can write this as the square root of 2 divided by the square root of 25. And then what does this become? Yeah, this is the square root of 2 divided by 5. Square root of 27 over the square root of 25. Okay. How can I rewrite the top? Yeah, 3 times 9. What's the bottom? Bottom is just 5. And so this becomes what? 3 square root of 3 divided by 5. Okay? Now, what if you had something that you really, let's just say, for example, let me do one real quick that, suppose I had something like the square root of 96, okay? Now, nothing is jumping out to me right away. This is what you need to do, and the factorization, the prime factorization, you should have done this in an earlier life. I look at 96. I know it is divisible by what number just by looking at it? By 3. What's another number is divisible? 4. What's the smallest number? 2. It's an even number. So let's just start with that. It's divisible by 2, and this is what? 2 times 48, right? 48 is also divisible by 2. That's 2 times 24. This is still yet divisible by 2. I keep dividing by 2, and I get this, okay? So what is this number? This is 2 times 2 times 2 times 2 times 2. What is that? That's 32. Do I see anything that's a perfect square? So like if I group them like this, what is that? That's 4 times 4, right? Yeah, so 4 times 4 times 2 times 3. So I can write this as what? This is 16 times 6, okay? If I can group these together, this is 2 times 2 is 4 times 4 is 16. Now what's the square root of 16? Yeah, so this is 4 square root of 6, okay? So if you have trouble just going to like, what do I need to make it out? Do the prime factorization, okay? You could have written this, this is 4. I could have said this is 4 times 4 times 2 times 3, okay? Square root of 4 is 2. Square root of 4 is 2. So that gives me what? 4 times the square root of 6. You get the same thing. So you'll have to be in the goal of being able to simplify radicals like this. Now, another thing that we need to do with square roots is another skill is simplifying square roots. In math, we don't like to leave square roots in the bottom of a fraction. We'd rather the square roots be in the top or the numerator of a fraction. The way you can take care of this is very similar to what we did with complex numbers. I can multiply this by square root of 2 over square root of 2. What is that number, square root of 2 over square root of 2? That number is what? 1. Can I multiply something by 1? Does it change it? No, it's valid. So what do I get on the top? I get 2 times the square root of 2. On the bottom, I get the square root of 2 squared, right? On the bottom, what is the square root of 2 squared? 2. Okay, so it's the square root of 2 times the square root of 2, which is 2. All of this is what? 2 square root of 2 over 2, which is square root of 2. Okay? So 2 divided by the square root of 2 is the square root of 2. 1 divided by the square root of 7. If I want to get rid of that square root of 7 on the bottom of the fraction, what will I multiply by? Square root of 7 divided by the square root of 7. And this gives me what? Square root of 7. What is the square root of 7 times the square root of 7? I heard several things there. The square root of 7 times the square root of 7 is 7. Okay? It's the square root of 7 squared. If you take the square root of something and then you square it, you haven't changed anything. Okay? It's the square root of 7 squared. These are inverse operations. Okay? So the square root of 7 times the square root of 7 is 7. Okay? Now, the next one's where it gets a little bit more involved, but this should look like something you did on that previous quiz. 1 over 1 plus the square root of 2. I can multiply this by 1 minus the square root of 2 over 1 minus square root of 2. What does that look like that we just did? Yeah, it looks like we did with complex conjugates when we were dividing by complex numbers. Okay, so now I just need to multiply. What is 1 times 1 minus square root of 2? What do I get on the top of the fraction? Yeah, 1 minus square root of 2. How do I multiply the bottom of the fraction? What happens? Yeah, the first terms multiplied together gives me 1. The outside terms give me minus square root of 2. The inside terms give me a square root of 2. And the last term, what is the square root of 2 times minus square root of 2? Negative 2. Pardon me? Yeah, just like in complex conjugates, what you see there, what is the square root of 2 minus the square root of 2? That's 0. So by design, I multiplied by this so I could get that to go away. So this becomes 1 minus the square root of 2 over 1 minus 2. What is 1 minus 2? Negative 1. So this is 1 minus square root of 2 over negative 1. So all of this is just 1 over negative 1 minus the square root of 2 over negative 1. What is 1 over negative 1? Negative 1. What is the negative square root of 2 over negative 1? Yeah. So there's your answer. Negative 1 plus square root of 2. You got to be, pardon me? Well, you're going to have to, okay? So you can do this. Let's pretend like you're in the 10th grade, and we'll be good, okay? Let's do the next one. 3 over 3 minus the square root of 3. What will I need to multiply this guy by? 3 plus square root of 3, or 3 plus square root of 3. Okay. What do I get on the top of this fraction? 3 times 3 is 9. And then 3 times the square root of 3, that's plus 3 square root of 3. And then on the bottom of this fraction, you multiply the first two terms together, you get 9. The outside terms, you get plus 3 square root of 3. The inside terms, you get minus 3 square root of 3. And what is negative square root of 3 times positive square root of 3? Negative 3. Okay. So this becomes 9 plus 3 square root of 3. What happens to these inside terms there? They go away, and you're left with 9 minus 3, which is 6. So you get 9 over 6 plus 3 over 6, the square root of 3. What's 9 over 6? 3 halves. What's 3 over 6? 1 half. Okay. So there's your answer. 3 halves plus 1 half square root of 3. Yes. Could you what? This right here? It is a fraction. 1 over 2. Okay. Okay. What I do think you should be expected to take 9/6 and turn it into 3 halves. Okay. I didn't explicitly say that on the previous test. There were some complex numbers that didn't quite get that far, but I'll make sure that it's stated. But that's a skill. You should be able to reduce fractions to their simplest form. Okay, so this was just getting us warmed up to work with square roots, because we're going to have to work with them in solving equations with square roots. Now, x squared equal 9. What numbers will make that true? 3. There's another one. 3 and negative 3. Okay. Now, without doing much work, you realize that when you square 3, you're going to get a 9. When you square negative 3, you also get a 9. So there were two numbers that made this a true statement. Okay. Same thing if I had x squared equal 5. What numbers make that true? Excuse me. X squared equal 25. What two numbers make that true? 5 and negative 5. Okay. So instinctively, you know that there are two answers to that problem. Okay. So here's where you got to take some care and caution in solving things with square roots. When you take the square root of x squared, it's not x, it's the absolute value of x. Okay. Because if I had x squared equal 4, you got two answers out of that. You got 2 and a negative 2. So the square root of x squared is equal to x. Okay? So when I'm solving x squared equal 4, when I take the square root of the left side, the square root of the right side, I get the absolute value of x is equal to 2. If the absolute value of x is equal to 2, what numbers can I substitute into this absolute value and get 2 for an answer? What numbers, when you take their absolute value, give you 2? 2 and negative 2. So your answer is 2 and negative 2. Now, what most people are going to do, instead of going through this step of the absolute value of x squared the square root of the x squared is equal to absolute value of x, they're going to skip over that step and just get a plus or minus in your answer. Let me show you what I mean by this. When you're trying to solve x squared equal 9, all you really need to do, when you get to the point, if you take the square root of both sides, all you have to do is just put a plus or minus there. Okay? You don't have to go through this intermediate step of the square root of x squared is absolute value of x. So when I take the square root of the left side, I get x equal plus or minus the square root of 9. What's the square root of 9? 3. So this is x equal plus or minus 3. Okay. You knew that without going through this. When x squared is 9, you know what the numbers are, but it's going to get a little bit more complicated in the ones that we're going to solve. So let's now solve a couple. Now, in solving this, I want to get on one side of the equation, whatever is being squared, I want to be by itself, okay? What is being squared here? X. Is 2x being squared? Yes or no? No, just the x is being squared. So I want to get the x squared all by itself. What will I do to get it by itself? Yeah, first thing I'm going to do is add 15 to both sides. This gives me what? 2x squared equal 80. What do I do to get x squared by itself now? Divide by 2. So I get x squared equal 40. Okay, so I've got x squared equal 40. in order, now I've got the x squared all by itself. My solution would be to take what on both sides? Square root of both sides. Over here, don't forget that what goes in front of this square root? Plus or minus, okay? So on the left, what's the square root of x squared? X equal plus or minus square root of 40. How can I simplify the square root of 40? This is x equal plus or minus 4 times 10. What's the square root of 4? 2. So x equal plus or minus 2 square root of 10. That's my solution. Okay? So, okay for a Friday afternoon? Okay. As long as Henry says it's okay, we're good. So. Okay, the next one. What is being squared? Not x. X minus 3. X minus 3 is being squared. That's what I need to get by itself. So what am I going to do first on this one? Yeah. Multiply everything by 4. And that's when you get x minus 3 squared equal what? Let's go with 64. Okay. Now I'm going to do what? Take the square root of both sides, and there's a plus or minus there. So what's the left side become? X minus 3 equal plus or minus the square root of 64. So this tells me that x minus 3 equal plus or minus, what's the square root of 64? 8. I'm solving for what? What am I solving for? X. So x is equal to 3 plus or minus 8. Do you think I would leave my answer like that? No. What would I do? Yeah, what's 3 plus 8? That's 11. What's 3 minus 8? Negative 5. So those are your solutions. 11 and negative 5. Now, what if I didn't believe that and I said, prove that those are the answers? What would you do? You plug them back in the original equation. What's 11 minus 3? 8. 8 squared is 64. 64 divided by 4 is 16. So you can, in algebra, you could always check your answer. Everything in algebra is checkable. So you get the time, you can certainly check your answer on that. Let's look at the next guy. What is being squared? X. So that's what I want by itself. First thing I would do is subtract 72. So that gives me what? 2x squared equal negative 90. Now what? Yeah. Divide by 2. And I get x squared equal negative 45. Now what will I do? Yeah. So I'm going to take the square root of both sides. What goes in front of this square root is plus or minus. Okay. On the left, what do I get? X equal plus or minus square root of negative 45. What kind of number is this going to be? No. It's a complex number. You've been tested over this, right? So, huh? That's 90. Okay. So, guys, how do I take the square root of a negative number? What is it going to have in it? Yeah. So this is going to be plus or minus. What is it? Negative 1 times 45. Okay. I'm having a bad smartboard day here. What's the square root of negative 1? I. So this is x equal plus or minus I times the square root of 45. Okay. Can I simplify the square root of 45? That's plus or minus I, the square root of 9 times 5, right? What's the square root of 9? 3. So this is x equal plus or minus 3I square root of 5. So, pardon me? So here's the deal. With I like to put it in front of the radical because if I had something like this, what's the danger in me writing it there? It's the same thing, but like sometimes people are a little bit sloppy and I don't know, is the I under the radical? Is it not under the radical? I don't know. So we typically just write it like this. Put the imaginary part in front, the square root on the end. Okay? You could write I3, but we don't write x3, we write 3x. Okay? We typically put the number first. So 3I times the square root of 5. Let's look at the next guy. What needs to get by itself? The x squared, so I need to add 7 to both sides. So I get 3x squared is equal to what? Negative 24? And then what? Divide everything by 3. X squared equal negative 8. Now I've got the term that's squared all by itself. I would do what to both sides? Square root, and don't forget your plus or minus. Okay. On the left, what do I get? X equal plus or minus the square root of negative 8. Anytime you see a square root and you've got a negative number, what's going to show up? I. So I can just go ahead and write this as x equal plus or minus I square root of 8. Just take that negative outside the radical and it becomes I. And then the square root of 8, so this is x equal plus or minus I, the square root of 2 times 4. So what's the final answer here? Yeah, plus or minus 2I square root of 2. Okay, is this starting to feel okay? We're combining radical properties, which you should know, with complex numbers. With the parabola. What form is this in? Vertex form. So does the parabola open up or down? Parabola opens up. What's the vertex? 1, negative 6. What's the equation of the axis of symmetry? X equal 1. Okay, it's an equation. Some people, like I said, on the test, they just wrote 1. You know, or some people would graph it. They would graph it correctly, but they would write it down wrong over here, which I wasn't sure how that happened. So 1, negative 6. That is this point right here. Okay? So that means that the axis of symmetry is a line that does this. Okay? How do I find the y-intercept? You plug in x equals 0. So if x equals 0, I get 2 times 0 minus 1 squared minus 6. That's 2 minus 6, which is what? Negative 4. Your y-intercept is a point, 0, negative 4. So 0, negative 4 is right here. Okay. That means there's also a matching point right here. Okay. Now, so I know what this parabola is doing. At this point, it's doing something like this. Okay. Now, what I'm interested is, where does it cross the x-axis? How do I find where it crosses the x-axis? What y is equal to 0? Okay. So y is equal to this. What will I set this equal to find out where it crosses the axis? Set it equal to 0. So to find out where it crosses the axis, you're going to say, what is this guy? It's 2x minus 1 squared minus 6. To find out where the y value is equal to 0, just set this whole equation equal to 0. And let's pretend like we just had a lesson on how to solve something like this. What will I do to both sides? Add 6. So I get 2. X minus 1 squared equals 6. Now I do what? Divide by 2. And I get x minus 1 squared equal 3. What will I do now? Yeah, square root of both sides. So you get x minus 1 squared equal 3. Take the square root of both sides and put a plus or minus there. So what do I get on the left? X minus 1 equals square root of 3. And then to solve, plus or minus square root of 3. To solve this, x is equal to what? 1 plus or minus square root of 3. So those are my x-intercepts. It's not nice, lovely numbers like 2 and 4, okay? So I got to figure out, what is the square root of 3 is about 1.7. So if x equal 1 plus the square root of 3, that's approximately equal to, I think, 2.7. If x is equal to 1 minus the square root of 3, that's 1 minus 1.7, which is about negative 0.7. So it tells me that if I wanted to be a little bit more accurate in my graph, I could come back here and say, so at 2.7, so 1, 2, somewhere about right here, and negative 0.7 is about, oops, what is it? Square root of 3 is about 1.7, so 2.7, 1 minus 1.7, wait, I did something wrong here. What did I do? Oh, 1, 2, oh, sorry, I did the point wrong. This point is 1, 2.7, about right here. There it goes. So now I can look at this graph and I can get a little bit more accurate with it. Okay, so this point right here, that is 1 plus the square root of 3, 0. And then this point you see right here is 1 minus the square root of 3, 0. I found the exact values of the x-intercept. Okay, so when you've got something in vertex form, you've got something squared. So the logical way of solving that is by taking square roots of both sides. Now, I'm going to do the same problem we just did. You don't have this in your book, but this is fair game for something that you might need to do. Here's the same parabola that we had. Okay, remember it was what, at 1, negative 6, and we did something like this, and something like this. Okay, how would I find where the y value is equal to 5? So look at it on this parabola. How many times does the y value equal 5? Where is y 5? Oh, here. How many points does y equal 5? There are 2 points here, okay? So y is equal to 5 on those 2 points, okay? How would I figure out what they are? Set y equal to 5, okay? So if y is equal to 5 and y is equal to that parabola, then what would I do? What would I do then to find these 2 points? I would set this equation equal to what? 5, okay? So if I set the equation equal to 5, I'm finding these 2 points. Now, here's the thing. What would happen if I set the equation equal to negative 10? How many answers do you think I would get? If I set the equation equal to negative 10. Anyone? Okay, if I look on the graph, there's no value at negative 10. So let's try that. Let's set this equation equal to negative 10. Okay, set the equation equal to negative 10 because I'm finding out what the solution is down here. I add 6 to both sides. So I get 2x minus 1 squared equal negative 4. Now I do what? Divide by 2. X minus 1 squared equal negative 2. Now I do what? Take the square root of both sides. So x is equal to 1 plus or minus the square root of negative 2. What's the square root of negative 2? Yeah, so this is x equal 1 plus or minus I square root of 2. What happened? I got a solution, but it's what? It's not real. Okay, that's why it doesn't show up on my graph. There is a solution, but it's a what kind of solution? Complex, okay? So when I look at my graph, there is no spot on there where the graph touches negative 10. But when I set it equal to negative 10, I do get a solution. I get two solutions. They're complex numbers, okay? So if I look at it, if I look at this graph, what kind of solutions would I get if I set this thing equal to 100? What do you think I would get? Real or complex? Real. 100 is just going to be way up there, so you're going to get 2 points where it equals 100. What about when I set it equal to negative 2? I get 2 points. What happens when I set it equal to negative 6? What do I get? You only get 1 point, which is right here. And we should have known that because if I set it equal to negative 6, that's where, what, negative 6 minus 1, I'm going to get, at negative 6, that's going to give me the vertex point here. So I only get the one solution. What is it? If I put a negative 6, this becomes what? Negative 7. Wait. Oh, sorry. If I set it equal to negative 6, the negative 6's go away, and you get x equal 1 is the only solution. 1, negative 6. Anyway, sorry about that. And then what about if I set it equal to negative 7? There are no real solutions, but there are complex solutions, okay? So that's what we're going to be doing. So what today we did was we took vertex form and we learned how to solve it. When I see you on Monday, we're going to take intercept form and figure out how to solve it. Question?